Okay, let's look at the same exact problem that we just did, but this time when we work it out, what if we look for the area under this curve here, same area, okay, above the x-axis and in between these two guys, but what if instead of integrating two separate functions and two separate deals and adding it all up, and what if you make a mistake? What if we integrated with respect to y? In other words, instead of having equations that say y equals, what if we had equations that say x equals, okay? So if I've got y equals the square root of x, and I want to know what x equals, then square both sides, and I have y squared equals x. That's the orangey colored equation here, the reddish orangey, probably reddish. Bad colorblind mistake there. On the other side, if I've got y equals x minus 2, then all I have to do is add 2 to both sides. And now I don't integrate on x numbers, I integrate on y numbers. Okay? And again, we notice that this point up here was the point 42. Okay? So I'm actually going to set up an integral now from 0 to 2. From 0 to 2. And when I do that, I do my furthest to the right, my stop function, minus my start function. So my stop function is actually here. This is where my area stops if I look at it and compare it with the y-axis. This would be my start function here because this is where my area starts if I look at it compared to the y-axis. So what do? You do start, or you do stop, minus start. And now you integrate it with respect to dy. And all of a sudden, instead of having to look at two separate things, you only have to look at one. And you can if you're in my class, you can punch this into your calculator. If you're not in my class and you've got to integrate this, then it just integrates to y squared over 2 plus 2y minus y cubed over 3 and evaluated from 0 to 2. Remember that. You're doing stop minus start, okay? So it would be 2 squared over 2 plus 2 times 2 minus 2 cubed over 2. And remember, if you put zeros in all those places, you just get 0. So 2 plus 4 minus, what's that, 8 divided by 3? No, 2 cubed is 8. 8 divided by 2 is 4. What have I got wrong here? Y, 2y, y squared over 2. Alright, I got my mistake right here. This should be cubed. So this is a cubed here, which is going to make this 8/3. So that's going to be 6 minus 8/3, which again will be 10/3 units squared. So there you go. There's finding the area between two curves. It's not very different from what you've been doing, but now you're going to have to pay attention to which function is on top, and if that changes, then you need to also account for that as well. Okay?